So we're going to have a look at question 15. So this is question 15 from the 2020 HSC Advanced Maths paper. So this is a sort of geometry / trigonometry style question. There's a few different ways to get the different answers. This is another one. Like some of the other questions at the start of the papers, towards the start of the papers, they're often high mark questions, which are not particularly difficult. These are good questions for you to get right because you are getting a lot of marks for relatively little effort. So we're given a diagram. We'll reproduce this diagram. Here, this is point P. There's a line that goes up to point A. Then there's a line that goes down to point B. This is 7 kilometers, and we're told this is 9 kilometers. All right. So Mr. Ali, Miss Brown, and a group of students are camping at the site located at P. So these people are starting at point P, this center point. Miss Ali walked with some of the students on a bearing of 35 degrees for 7 kilometers to location A. Okay, so immediately we have information. The bearing is the angle from north clockwise. So that means this angle here has to be, this angle in here has to be 35 degrees. Miss Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers. Okay, that means this angle is going to be 100 degrees, and we're told she walked for 9 kilometers. So we're getting this information from the question. You don't have to add it to the diagram, but you can if you want as you're going along. Often it will help to add these pieces of information to the diagram because it'll make later stuff easier. So we have to show that angle APB, so show that angle APB is equal to 65. Well, angle APB is the angle formed by starting at A, moving to P, and then moving to B. Now, because we've been given the two bearings, we know that angle APB is going to be the difference between them. We were told this angle is 35 and this angle is 100. That means angle APB, when added to 35, must give us 100. So this is just going to be the difference. This will be the bearing to B, which is 100, minus the bearing to A, which is 35. So this is 65, and this is degrees. This is all in degrees in this question. So this is the answer to question A. This was another one where using the graph is really helpful because if you write things down properly, it's probably just going to give you information, right? That's why they've told you this in the question. So writing these bearings down immediately makes it visually obvious from the graph what the other angle has to be, and then you're just doing a subtraction. This is 1 mark, and this is just for the answer. Question B, find the distance AB. All right, so this can be done really easily. I'm going to redraw this diagram with the information we now have. I'm going to redraw a slight variation of this diagram, going from P to A over here, going from P to B down here, and then the connection between A and B looks like this. So this is A, this is B, this is P. We know this is 65, we know this is 7, we know this is 9. Now we've been asked to find AB, which is this length over here. This is just a non-right triangle. So you can just use non-right trigonometry in this case. In fact, you're going to be using the cosine rule. So we're going to label some sides here. This will be C, and then the other two will be A and B, and this will be angle capital C. So our cosine rule for finding a side opposite an angle where you know both side lengths around that angle is C squared is A squared plus B squared minus 2AB cosine of C. So if we plug A, B, and capital C in, we're going to get C is equal to the square root. This potentially will simplify down nicely. It's also possible that we're just going to put it into the calculator to find the answer anyway. The markers notes do this in a slightly unusual way, but if we put this all in the calculator, it's going to give us an answer. So we have 7 squared plus 9 squared minus 2 times 7 times 9 times cosine of 65. Now 65 is not a cosine exact angle, so that's a sort of indication that the calculator is just going to evaluate this for you. So when you end up putting this whole thing into the calculator, you're going to get 8.76. 8.76 with a whole bunch of other decimals. And so the marker notes are going to have us round this to 2 decimal places. It doesn't actually say how to do this. This is not necessarily the exact solution here, but 8.76 ... with a whole bunch of other decimals. This is going to be the answer in this case. And this is, of course, in kilometers. Right? So if the question specified to you very strictly that you were to use a particular rounding, so if they said, oh, in a 2 decimal place, 1 significant figure, then you would have to follow that. Here the question actually doesn't specify, it just says find the distance AB. So in the marker notes they say provide a correct solution. For 1 mark they say attempt to use cosine rule to find the distance. So this means so long as you have 8.76 or something similar, that's going to get you the mark here. And we'll go through the more specific marking towards the end. Now there's a third part to this question. Find the bearing of, so this, before I go over this question, bearing questions can have very unusual wordings. So if you encounter bearings questions that are based on trigonometry or multiple items that have multiple different positions and you're finding angles between them, read the question very carefully, because changing the order of the words or changing one word can completely change what you are being asked. So this is something you want to be very aware of, because if you know how, these are not hard questions. So if you would like to do reasonably well in this exam, you have to get these questions right. They have to be 100% pretty much in the early part of the exam anyway. So read bearings questions very carefully. Make sure that you understand which bearing you are being asked for. It's an incredibly common student mistake to sort of try and rush through them, just go, oh yeah, whatever bearing, find whatever bearing they can, find it, it turns out to be the wrong bearing, and then they lose marks that they could have got. So this is incredibly common. I see this every year. Students do this. They make this mistake routinely. So find the bearing of Mrs. Brown's group from Mr. Ali's group. So of Mrs. Brown's group from Mr. Ali's group. So this is a bearing centered at Mr. Ali's group. So if we draw our diagram again, like so, we know this is 65. This is Mr. Ali's group up here at A. The bearing is from his group. So if we draw a little compass down here, we are after this angle. And then Mrs. Brown's group is down here. We could draw a little compass around this as well. But we are not necessarily after bearings down here. We are really after this bearing here of Mrs. Brown's group from Mr. Ali's group. And we have to give our answer correct to the nearest degree. So when we look at a question like this, the bearing is really broken up into 2 parts. Right? There is a section here, which is 90 degrees, and then there is another section down here, which we might call, it doesn't really matter what we call it, let's just call it alpha. So the bearing we are after, we know, is 90 plus alpha. The alpha value might be a little bit challenging to find in this case. It's not necessarily immediately obvious how this works, so that value might be a little challenging. If we think about how we started doing this question though, the whole question becomes a little bit easier. So we knew initially that this was 35. We can use geometry to infer that this angle is 35. This is Z angles. And this is year 7 through 10 basic geometry. This is essentially a Z. These compass lines, this one and this one, are parallel. And so we know both angles in this case are 35. We know this is 90. We know this must be 65. And we don't know what this angle is. We can call this beta. But we do know this distance is 9, and we do know this distance here is 7. So this diagram looks a little bit complicated, right? But this is all of the information that we have. And this is what we can do in order to find that alpha value, in order to find our bearing. Notice, because we know this is 90 degrees, we can think of the bearing as being 90 plus whatever alpha is, or we can think of the bearing as being 180 minus whatever beta is. Obviously alpha plus beta are 90, so if you have one of them you can always find the other one. But in a question like this you can do this either way. Sometimes one of the ways will be better than the other. So we know that this distance is 8.76. Now that's convenient because it means we know all of the side lengths of the triangle, so we can find this angle. Right, so we're going to draw just our triangle again. Looks like this, looks like this, looks like this. This is 9, this is 7, this is 65, this is approximately 8.76. Depending on how this is rounded, we'll change the answer by a very small amount. 8.76 is going to give us the correct answer when rounded to 1 degree. If this is off by a very small amount, it's unlikely to change the degree once you round to the nearest degree. It's just not going to happen. So we know these lengths, and now we can just use another trigonometric rule to find this angle, which we can call theta. Theta minus 35 is going to give us beta. 180 minus beta is going to give us our bearing. So this is what we're going to do now. Here we'll use sine rule because we have an angle side pair here with one unknown and an angle side pair here where both are known. So we get sine theta over 9 is equal to sine 65 divided by 8.76. Multiply both sides by 9. This gives us sine of theta is equal to 9 times sine of 65 divided by 8.75. Now we just want to find the theta on its own. So the theta on its own will be arc sine. This is the same as sine minus 1 or shift sine on the calculator. Arc sine is just a formal name for this. 9 times sine of 65 divided by 8.76. Now, when we evaluate this, this is going to give us a theta angle of 68.6, which is going to round to the nearest degree. You can choose to round at this point. The marker notes actually round at this point. You could do the subtraction first, but the marker notes already round. This is 69 degrees, and this is to the nearest degree. Now when you do round, always tell people that you've rounded, so don't just round and then leave the answer. So 68.6 with a whole bunch of other decimals. This rounds up to 69 degrees. This is the rounding to the nearest degree. Now the bearing from earlier in the question, we established this much earlier, that the bearing is 180 minus beta. where beta was this little angle in here, is 180 minus beta. But we know that beta is actually equal to the full angle, 69, minus 35, because there is a 35-degree angle over here, a beta angle over here. The sum of these two is this total angle, which we just calculated as 65. This is 69, sorry, when rounded to the nearest decimal. So this means beta is 34. Given that beta is 34, the bearing is going to be 180 minus 34, which is 146 degrees, and this is also to the nearest degree. And this is the answer. Now this is a slightly more complex, it's not too hard, it's just non-right angle trigonometry. It's got a little bit more working, and you have to think a little bit about the problem in terms of the fundamental geometry, but it's not too bad, right? We're not dealing with, especially for the first parts, we're not dealing with any sort of unusual integrals or weird kind of continuous or discrete distribution problems where you have to use multiple topics in a row in order to do this. This is mostly a bit of geometry and then some trigonometry. So the marker guidelines here, for the first part, you really just need to get the 65. The correct solution gets you the 1 mark. And then you'll have you should have some working for that. 100 minus 35 is going to be suitable. For part B, you can get 1 mark for attempting to use cosine rule to find the distance AB, but failing to do it correctly. So if you use cosine rule to find the distance, that will get you some marks, but to get 2 marks for section B, because B is out of 2, you will need the use of cosine rule and then a correct solution. So correct solution is the criteria for 2 marks. Now when we go down to C, it's a little bit more, C is a little bit more complicated because there's quite a few different ways to do it depending on how you think about the problem. You get 1 mark for finding one of the angles in triangle APB which you don't already have. And so you have 65, that's one of them. If you can find another one, you get a mark, or equivalent merit. And that will really mean if you have some substantial working that's getting you close to finding the bearing, but not quite getting you the bearing. Right, and the markers in the marker center will specify very strictly when they're marking what it is that exactly means. But if you have good working that's getting you reasonably close to having a bearing, it's likely to get you 1 mark. So this would be, in this case, there's actually quite a lot of this here. This would take us all the way down to doing the arc sign pretty much, because we'd have to get this angle. And then the second mark will be for providing the correct solution. So somehow, whether you're using this method or some other method, you have to get to the nearest degree that the bearing is 146 degrees. I'll stress that this is one method, right? There are a bunch of different methods. This is essentially the method that the marker notes use. It's quite a good method. It does have a fair bit of geometry in it, which to some students might be slightly surprising. But geometry used to be a very, very big part of the advanced maths course and the higher maths courses. Geometry's role in the courses in recent years has been somewhat reduced. You still see it here though. Right? This is where the geometry appears. You can use geometry in certain questions in order to make them a bit easier. Right? That's what happened in this question. Trigonometry and geometry were used together in order to do this question. Not an overly difficult question. Should not take students too long in the exam. Very generous marking. Right? 5 marks is quite generous.